right, so this next page in your packet we're going to call practice. Actually, you have 2 pages in your packet to practice. Your next one is something that looks like this. And we'll get to that a little bit later, but for now, we're going to work on this practice. And what's kind of cool about this practice is you can do the FOIL for each of these. And when you're doing the FOIL, you're going to start seeing some special patterns that end up happening. So I want you to just pay attention to what you see as you go and think about multiplying each of these binomials. Okay, so x times x is my first. X times negative 3 is going to be, oops, that's x squared. Negative 3x is my outside. My inside is positive 3x. And my last is negative 9. So my first term, my outside term, my inside term, and my last term. Do you see anything interesting about this? When you combine like terms, you end up with x squared minus 9. Interesting. All right, let's do another FOIL. Our first terms, 2x times 2x is 4x squared. Our outside terms is positive 4x. My inside terms is negative 4x. And my last terms, negative 2 times positive 2, is negative 4. Do you see when I go to combine like terms, I have a 4x squared, positive 4x, negative 4x is a 0 pair, and I'm again left with a binomial as an answer. So we'll keep working on these. My first terms, x times x, is x squared. My outside terms, x times negative 8, is minus 8x. X times positive 8, 8 times negative 8. And again, do you see what's happening? X squared minus 64. 4x times 4x. 4 times 4 is 16. X times x is x squared. 4x times 9 is 36 x's. Negative 9 and positive 4x is minus 36 x's. Negative 9 times 9 is negative 81. A positive 36x and a negative 36x is again a 0 pair, leaving me with 2 terms as a binomial instead of 3 terms as a trinomial. So here I have a generic pattern. And we can go ahead and do a times a is a squared. A times b is positive ab. Negative b times a is negative ab. And negative b times b is negative b squared. And again, do you see this 0 pair, plus and minus ab? Leaving me with a squared minus b squared. And it doesn't matter how many variables I have. So 25, 5 times 5 is 25, a squared, c squared. And then we're going to have plus 5abc is my outside product. My inside product is minus 5abc. and my last product is minus b squared. Again, do you see? I have my zero pair, leaving me with 25a squared c squared minus b squared. So let's talk about the patterns that you see. Pause the video and talk about a couple things that you notice happened every time that this was true. Okay, so here's what I saw. I had two binomial factors. Remember, binomial means that there's two terms in it, and the factor means it's being multiplied together. So they had the same values, an A and a B, but what's interesting is they had opposite signs. And that is when we're going to call them as sum differences. We're going to call this part of the sum difference pattern. The other few things I noticed are the fact that the product of my first terms was always a perfect square. And that makes sense because A times A, if they're the same values, it's going to be a square. Next, I look at my middle terms, where my O and my I, and that always gave me what we're going to call a zero pair, because I always had a plus minus, and therefore it always canceled out. My last terms also gave me a perfect square, but guess what? It was always negative. So that's an interesting pattern that we saw every time that we have this, and we're going to get to know this well as the sum difference pattern. So I want you to remember, whenever you see those identical values, you're going to end up with that zero pair from my middle terms. All right, so here's our next set of values. Let's take a look and see what I see here. When I take my x and my x, I get x squared. My x times my 3, 3x. My 3 times my x, 3x. My 3 times my 3, positive 9. I don't get a zero pair. Instead, what I get here is a double. So instead of it canceling out, what I end up with is a perfect square and a double and then another perfect square. So let's try another one and see if that same thing happens again. I want you to think about, why does this happen this way? X times x, x squared, x times 8, and remember that 8 is negative. Notice that is not a zero pair, it is our double. So when I add those two terms together, I end up with a result that's a square and a double and a square. If you see this exponent up here, you want to make sure that that's rewritten as 2x plus 2 times 2x plus 2. The biggest mistake that people will make is they'll go ahead and they'll think that that's 4x plus 4. And I got to tell you right now, that is the wrong answer. Because look at what happens when we take the time to FOIL. 2x times 2x is 4x squared. 2x times 2, 4x. 2 times 2x, 4x. 2 times 2 is 4. 4x squared plus 8x plus 4. Check it out. It's not equal to 4x plus 4 because they forgot about that middle term. All right, let's do this one. 4x times 4x is 16x squared. 4x times negative 9 minus 36x minus 36x plus 81. 16x squared minus 72x plus 81. So we can see our pattern. Whenever I have a binomial squared, it might be in your best interests to rewrite it so you don't get confused about what that square is doing out there. You can't distribute that square, because if you do that, you wind up missing out on that middle term. Something that's going to happen every time is you're going to end up with a double, because your outside and your inside terms are going to match perfectly. 5AC times 5AC is 25AC. Times B is 5ABC. And we're going to repeat that because all of my terms are identical. My first term is a perfect square because its factors were identical. My second term is a double because I had two of them for my inside and outside. And my last term is a perfect square. All right, so take your time and go ahead and reflect on what special patterns you see and see if we match. Okay, so here's what I came up with. When I have two values that are identical, they are both matching A's and B's, and their signs are the same. What that ends up giving me is a perfect square. I have identical factors, they have the same signs, and my result winds up being a square double square, which gives me a square double square pattern as an answer. Here's the special patterns I see. My first terms also wind up being a perfect square, same as up top. My last terms also end up being a perfect square, same as up top. The difference here is what happens to our middle terms. When they were a zero pair here, they canceled out. When here they're a double, I wind up with twice that value. So that's going to be a big thing when we talk about factoring, which is our lesson that's going to hit us next week. Okay, so here we go. This next part talks about having multiplied 6 different examples of multiplying. And then here we go back to having that visual representation of what they look like with having our squareds and our x's. So what I want you to do is I want you to multiply, and then I want you to match it up to which one do you think best shows those values being multiplied. Pause the video and give yourself a chance to finish. All right, so check it out. When I multiply x times x, that's x squared. I'm going to match that up with this one here with e, because this is x times x, which gives me x squared. When I look at x times x plus 1, that gives me x squared plus x. I'm going to match that one up with a, because if you look at it, this is x plus 1, and this is an x, and then I can think about those being factors of that product. Okay, so I have 2x times x, that's going to give me 2x squared. So if you think about it, this is x plus x, or 2x, and this here is x, which means this one's got to match up with C. If I have 2x times x plus 1, my answer is going to be 2x squared plus 2x's. And if I look, that one matches up with f, because this is an x and a plus 1, and this is 1x squared and another x squared, which is going to be 2x squared. 2 x's. Okay. Number 5 is where we first get into our first instances of FOIL. And you can see when I did this one, I had my first terms product was x squared. My outside terms was my x. My inside terms was my 2 times x. And my last term was 2 times 1. So my FOIL helps me do that. I want you to take a look at the 2 that are left. If I have x squared and 3x plus 2, it's going to equal this one. But let's go ahead and talk about when I have a factor and a factor times a product. This is going to be x plus 1, which is the same as x plus 2. This is the same as x plus 1. And I can see where my x squared, my 1, 2, 3 x's, and my 2 add up to give me that polynomial. My last one here, I have my x squared and then I'm going to be multiplying that. I have x plus 1 plus another, which is where I get my 3. And I have my x plus 1, which is where I get that. And you can look at x times x is x squared, and 1 times x is x, and 1 times x is x, and 1 times x is x. X times 1 is x, and 1 times 1, 3 times, is what gives me 4 x's and 3, which means this one is D. And of course, this one is B. All right, good job. Let's take a look at the back. All right, if I'm talking about the area of a rectangle is equal to length times width. So I'm going to say that my area is equal to 3x minus 1 times 2x plus 4. This is a great example of an application of needing to FOIL. So my area is going to be equal to my first terms is going to be 6x squared when I multiply 3x times 2x. My outside term is going to be 3x times 4, which is a positive value, so I'll go ahead and include the plus sign. My inside term is going to be negative 1 times positive 2x, which is going to give me negative 2x. And my last term is going to be negative 1 times 4, which is minus 4. So my answer in standard form is going to be that my area is equal to 6x squared plus 10x, because I'm going to combine my middle two terms, and then minus 4. When we look at B, we know that an area of a triangle is equal to 1/2 base times height. So my area is equal to 1/2. My base is 2x minus 3. And my height is x plus 7. So we're going to go ahead and multiply these parts together first and talk about that 1/2 in a minute. So area is equal to 1/2 times our first terms is 2x squared. Our outside terms plus 14x. Inside terms minus 3x. Last terms minus 21. So my area is equal to 1/2 times 2x squared plus 14 minus 3 is 11x minus 21. And if I wanted to, I could distribute that 1/2 and continue working. All right. When we talk about the next example, we have consider the following models. We have a positive x squared and a negative x squared. We have a positive x and a negative x. We have a positive 1 and a negative 1. So when we talk about what polynomials represented, I have 1, 2, 3, 4 x squareds. And you can see that for each of these examples. So that's not going to help me pick. Okay? I have 1, 2, 3, 4, 5, 6 x's. But I also have 1, 2, 3, 4 negative x's. So that's going to give me a positive 2x in the middle. So far, that's my best option. Let's talk about the last part. 1, 2, 3, 4, 5, 6 negatives. So that fits that. C is my answer. Okay? Based on the models for x squared, x, and 1, which product is represented by the diagram? So if this is x squared, I have 1, 2 x squareds, 1, 2, 3, 4, 5 x's, and 3 is a constant. Now if you'll notice down here, I don't have that answer. I don't have 2x squareds plus 5x plus 3 as my polynomial in standard form. They're asking for the factors. So I got to go back up to my problem and know that I get x squared as the result of x times x. I get x as a result of 1 times x. X squared is a result of x times x is x squared. This is an x that has to come from x times 1 and x times another 1 and x times another 1. So if you look at what I have here, if each of these were added together, that gives me 2x plus 3. If each of these were added, that gives me x plus 1. 2x plus 3 times x plus 1. There's my answer. All right, good job. Keep working.